Alright, hey class, this is Young. I'm pretty much doing this recording just so you guys some tips on how to use some of the diagramming tool, especially Draw.io, the tool that I recommended in the announcement. So very quickly, right? Let me just close this, reopen it. Blank screen. To use Draw.io, literally just type Draw.io into your web browser. It is an online diagramming tool, and it allows you whenever you make any diagram, you have the options of either save it to your local computer or save it to your Google Drive. So you're never gonna lose it, especially if you save it on the cloud through some cloud storage like Google Drive. So I would just choose create new diagram. When you choose create new diagram, there are options over here that you can select. Am I still recording? Yes. That you can select. So if you do basic, it's just gonna be a blank diagram, business. These are just templates that you can follow. For us, primarily we either going to be at software, and if you just hover over, you can see that they have different UML diagram for classes, right? Database diagram, and then UML Venn diagram. Now if you just go to UML, you see they also have model for activity diagram. If you just double click on it, it's going to show you the model. Okay, but what happened in the case where you don't have any model to use, and let's just assume you don't have any model to use or any template. So I would go to draw.io and make a new diagram, and I'm just going to do a blank diagram. Okay, so for today, let's talk about activity diagram. It is probably the easiest diagram in your entire software development career. You're going to see people use this a lot, especially when they're not comfortable drawing out the actual architecture of the system. In cases where you inherit system from somebody, and you may not know a lot of details about the system, it's difficult for you to draw the complete architecture diagram to represent your system. So a lot of time, software engineers prefer to draw activity diagram just to show all the processes that their system have. For us, this recording is both a tutorial into Draw.io as well as activity diagram. For activity diagram, alright, it's supposed to represent a process from start to finish. When I say a process may have multiple steps. So let's assume the process of applying to graduate school. Alright, that process consists of the following step. First, you obviously need to research about the grad school that you want to enroll in. Then you need to know the requirements. Then you have to fill out your application. You have to let the school review your application, and when they review, they either approve or don't approve. And if they don't approve, then you may be missing some documentation. Right, so you have to provide all the missing documents. So those are the actions or the steps within a process. Each of those steps are what you have to show in your activity diagram. So the entire activity diagram will show the activities that are required in order to apply to a graduate school. Okay, for activity diagram, there's really two symbols you have to remember. First is the box, a square or rectangle box. Okay, this box should only have verb. You should only use verb in this box, and it should be the actual step that need to happen in this process. You would connect step A to step B, right, using the little arrow. Right. As now, if you recall, I literally just do basic diagram, and these are the general boxes that I can use. So if I connect it, alright, now I have two boxes connected to one another. So let's just say I'm trying to do activity diagram for graduate school. Okay. If you want to enlarge the text, look to your right. Alright. I mean, jar.io is so great. It's free. It's portable, literally online, so you can use it whenever you have access to internet. So the first thing for graduate school is I need to do a very basic one because I just want to show you guys how to draw boxes or diagram using jar.io. So first, I need to fill out application. Right, fill application. Now, before you start though, if you a lot of time, people don't really be formal. They just have boxes connect to one another. But if you really want to be formal, if you want, to make it look real formal in a document that you would hand over to other software engineer from other team. If you just do it for your team and you don't need the box, you don't need the star and the end symbol. But if you're going to have this in a document, then I recommend you should follow our the syntax of an activity diagram. So you need a star symbol. As you can see, I don't have any star symbol here. I would first try to search for it, see if they have anything. So I just type star. Conveniently, they have the star symbol here. So I would just connect it to my diagram, right? Just drag the arrow to touch the box. Now whenever you drag it, everything is connected. Alright, see? Beautiful. Okay, now fill out the application, and then the next step after filling out application, right, is for the school to review them. Right, now as I can say, activity diagram really only have two symbols that you should remember. One is the rectangle boxes, and they should be the actual activity that needs to happen in order for you to achieve this process. So now these are the activity in review application. There are two choices. You either get approved or you get rejected, right? So whenever you want to solve, basically that means you're going to have different paths that can happen. When you have different paths like that, you should use a diamond shape. So in this case, I have a diamond shape, right? Now this diamond shape would be the decisions. Reject. You can either choose. You would choose one of the two outcomes here. You either type reject or you type approve. In our case, we can do reject, right? So let's just say reject. Question mark. That is a decision node. Then literally just look for another arrow here. Drag it over. Oh, whoops, not like that. Alright, just drag it over. Oh man, I can't see. There we go. Yeah, I got LASIK, but my LASIK failed. I guess I can't really see. Reject. Now you're gonna have two options to make. So reject. When you reject, let's do a happy path. You fill out your application. The school review the application. Did they reject you? No. Alright, so you have this, and you just double click on the body of the arrow. It will have some text. You just type no. Okay. If you didn't get rejected, that means you get accepted, right? So you would type in here application approved. Alright, application accepted. And then now you would do AND. So let's type AND such. So convenient. I have an AND symbol. I'm gonna leave them right here. Okay. Let's leave them right here. You know, a lot of time, what I recommend is to do the diagram on a piece of paper. Once you have finalized how your diagram would look, then actually go on to use any of the actual diagramming tool to do your diagram. That will save you so much time, because otherwise you have to rearrange them just to make them look good, right? So just do them on a piece of paper first, and then now actually finish. So application accepted, done. Alright, that's my happy path, right? Happy family, everyone happy. You apply to Kennesaw Graduate School, you got accepted. Then you're gonna have to take me again if I'm still around. So application accepted. That's the happy path. Start, fill application, review the application. Did the application get rejected? No. Okay, it got accepted. And now in the case where it got rejected, right? So let's leave them right here. Now it doesn't matter if you draw your arrow, if you branch your arrow from this angle, this angle, this angle, or this angle. Doesn't matter. As long as they're coming from this diamond shape, then you should be okay. So if you didn't get accepted, right? So, meaning you get rejected for whatever reason. I mean, if you ever do get rejected, just email me. Trying to help you. I don't have much power because I'm only a part-time professor, but I do what I can. Yes, okay, rejected. And then usually when it's rejected, right? If you want to end your diagram now, that's fine too. You don't care what happened next. But in this case, let's just say it's rejected. Alright, and this should be the reason why it was rejected. You can go straight here to end if you want to, or if you want to start from the beginning, you could. So it rejected. So here is say needing more document, right? Let's just assume you need more document. Rejected, why? Because you need more document. So now you gotta go back, fill out the application again, right? So basically follow this process again. Okay. Okay. And I don't want to have this little arrow symbol here, so I would look to my right. Your right, on your right hand is where you can edit the property of any of your shape. So I don't want to have that little arrow. I would just not have it. Where right here, none. I see, none. Now I get another one. Point to this. Right. So that's my diagram, right? That's my full activity diagram for Graduate School. Very, very simple. So you have easy.io is. Start, I fill out the application. The application is reviewed, right? The application was rejected. It needs more document, so I need to go back and fill out my application again. The application did not get rejected. It got accepted, and okay. Cool. Alright, so that's the activity diagram here. That was very, very simple. Now, let's quickly talk about software architecture. So I'm going to save this diagram. I'm going to save it onto my device. Okay, so it's loaded here. If you open it, you realize that it's only have XML files. So these are XML format. Don't worry, it's just the way that Draw.io tool save data. So they just pretty much convert everything to binary data, so they can save them. and then but if you open this again in chart.io, so if I'm closing this right now, close, right, and I opened it again and I choose open existing diagram, I just give it my file. Where should it be? Yeah, boom, boom, boom. It should be in download, right? Where is it? Untitled diagram. Yeah, I forgot I didn't give it a name. If I, oh, that's the wrong one. Oh, this one was the one that I did before, just so I can show you guys this. We can use this as well, but I don't want to show this right now. Let's see, open from device. Where did I save it? Untitled diagram one. Dang. Alright, see? Just open it and then you can make modification as you want to, okay? Alright, so let's talk about a quick. Let me do another one. Whoops. So this is done. Let me just go to, you can make another page too. So let's say this page is just activity diagram. Okay, now I'm gonna go to another page and this is actually my high level architecture. Okay. Alright. So let's assume I have some requirement. Okay. Sorry, I'm a big Korean fan, Korean barbecue fan. So those are just the little recommendation that the IBM architect recommended for me. So let's assume these are some of the non-functional requirements, right? Their system, their database should never go down. Okay, their system should respond within 1 millisecond of user click. Okay, actually let's just say the system should respond within 1 millisecond user click. The system should, that's fine. Let's just make it 3, make it more realistic. So 3, database should never go down. Okay, so those are the two non-functional requirements that I have. Alright, and assuming this is a web application. So before I do anything, I usually try to think of all the major parts that my system would have. And this is just a blank diagram again. For a web application, right, I would basically have front end, right? Then I would have, you can also copy and paste, right, and just change the text. I would also have backend, okay? And I would have a database, okay? Okay. Now, this is a regular web application, right? Front end to display data, back end to process whatever user action is, and database to store the data or to fetch data that the user requests from. Okay, and this entire thing will be wrapped. This entire thing represents my application. All right. So when you have this, you see it cover all my charts. So just right click, do to back. See, now you can see the chart again, and I'm just gonna label this database, right? Just to make it real clear. And this whole thing is my application. Oops, it got so small. That sucks. There we go. Let's go this way. Database, backend, front end. Alright, see how it have the aligner for you too? Okay, and let's assume this is my application. Let's just call it some some what do we like? We have a lot of gamer in it, so some game design website. Okay, this is a game design website. Now that's this website is my actual system with front-end, back-end, and database. Alright, so now the requirement was, or actually, let's do some more. Okay, now I want to have an actual user, so just type user, drag this little stick figure guys here. It looks pretty cute, and obviously, right, whenever the user wants to access your application, they need to go through the web browser, so HTTPS. So this is this represent that layer, right? So very quickly, okay. Now, how does this work? The way this works is user send a request to your web browser, okay? Then it will pass through the web browser. Oops. And hit your application directly. Okay, it's gonna also hit the front end of your application, right? And obviously, whatever the user action is, this is gonna hit the back end, right? And the back end is gonna connect to the database to do pullback data. So assuming the scenario is that I messed up. Assuming the scenario is that okay, so I want to go to a game design website to look at some cool game design. So when I go in, I want the website to show me all the design that it has on its website, right? Like design template. I would log on to my computer, open the web browser, and I would go to the HTTP address. I would first see the front end, right? But the front end know that I'm requesting to view all the template on the site, so like the home page. So it will contact the backend to get back data that is displayed for the home page. The backend will contact the database in order to get back data for display. Alright, and obviously you would have another path going back to show the response, from the system. So when I hit the database, the database should point back here. Okay, alright, hold on. So make this none, right? And make this side an arrow. These are the side. Okay, represent the response from the database, and make it a lot bigger. Okay. Make this a lot bigger too. Make this a lot bigger too. Wow, that's too big. Now I really gotta make this a lot bigger. Okay. So database with response, and you want to doesn't matter how you want to document this response. I usually just use dotted line, just to show the difference. Database would respond to this request, and same thing, the backend is going to respond to the user request, right? And the front end will then display the page back to this browser, and the browser will display the page on the user computer, right? So already this is the very high level of a game design website. I need front end, I need back end, and I need a database. And all of this is my system, right? So when I hand this over, to the lead developer or to anyone on the team, they would have to code the front end, they have to code the back end, and they have to code the database. But now the requirement is that the database should never go down. Okay, so in order to make it never go down, right? It's real easy. How does something never go down? You almost never could guarantee that something never go down. The only way for you to do it is to have many instances of that something, so that when one instance goes down, you still have the other instance to back it up. Okay, so now within my architecture diagram, the database, instead of only having one database, I'm going to copy this and actually have another instance of my database, right? So database 1, and this is database 2, and they are the exact same database. Okay, so now the backend, and I'm gonna move it down here now just for ease of displaying. Okay, so now the backend, whenever it get data, I'm gonna call this when. Okay, so all right, it's almost never possible to guarantee something would not go down. Alright, the only way to prevent that is to have data redundancy, so have many instances of that something. But when you have many instances of something, how do you make sure they actually all link together, all working together? For that case, a lot of the people would use something called load balancer. Okay, the load balancer. So this is my database load balancer. What a balancer do is that whenever someone requesting data from it, it does a round robin. You can configure your load balancer as well. So let's assume this is another component in my system, and all it does is to appropriately distribute the request to either my database 1 or my database 2. Okay, so now because I have two instances of my database, I gotta make sure that if user 1 requests to see the home page, when the backend try to pull data from the database, right? That request will only go through one of the database, because the load balancer will either send it to database 1 or send it to database 2. But if I have two actors, one trying to access the home page, one trying to access a specific page, okay, like the About Me page. Request 1, when it gets to the load balancer, assuming they issue the request at the same time, so when it gets to the load balancer, one of them will go to database 1 and one of them will go to database 2. Okay, that means the database, all the database instances have to also be able to link up to one another. They have to be able to replicate data from one another, so they both have up-to-date data from each other, right? So load balancer, and I'm just gonna say, oh, okay. So let's just say that's the response from the load balancer. Oh, because it's attached. There we go. Okay. Now have this request. Okay, the database load balancer pick between one of these. Alright, let me take this box out first, it's annoying. Okay. Yeah, if it's annoying, just take it out, add it in later. I just want to show that this whole architecture is my system. Okay. Yep, a lot of architecture just makes sure things look good, right? So actually, I'm gonna stop editing like this. You guys have the idea. Okay. And this is the response. Alright. So I have this actor. Assume I have two actors. Both of them issues their HTTP web request at the same time. Then obviously, if one guy requests to view the home page, one guy requests to view the about page, both requests will hit the backend at once, and they're gonna go to this database load balancer, at which it will redirect request A to database 1 and redirect request B to database 2, right? And within their database, I would have a process. So I need a component that's called data replication, right? So they always have each other data. Okay. So you already have my front end, back end. It's gonna hit the database load balancer, data replicate. So if I just look at this system, I see that I need 1, 2, 3, 4. I need at least 4 different components. One is the front end, one is the back end, one is the load balancer, taking in requests and be able to either route them to database 1 or route them to database 2. And one is the data replication to continuously wrapping data between these two databases. Now, if this database go down, right? If it go down, then my database load balancer should be smart enough for the coder when they program it should be smart enough to always route it to the available node, which means it's always routed to database 2. And because database 1 is down right now, the data replication cannot happen. But because I have two instances, when one go down, the other will still work, but they will just take on a lot of the stress from all the requests that the user make. Now, assuming IT people or software development team fixed the database one and brought it back up, right? Then the data replication will happen. This piece should automatically replicate data so that this will bring database 1 up to date with database 2. Okay. Now this is data reliability. When one go down, the other is still available. But also for speed, right? It has to process very fast. So for speed, assuming this database setup is active, meaning request or the load balancer can route request to either database 1 or database 2. Both of them are active and running at the same times. But if you want to set active, passive, right? That means only database 1 will run. And the load balancer will not route the request to database 2. Okay, so it becomes like this. This still satisfies database reliability, because when database 1 go down, the load balancer still aware of database 2. But the way this configure, right? And you can make a note. This load balancer will route requests to the active database only, so it will never route to the passive database, but it is aware of all the database that are under that it can route to. So when database 1 is down, right, there should be some configuration in the database load balancer to automatically now route information to database 2, and it will make database 2 become the active one while making database 1 the passive one. Okay, and whenever we bring the instance that was down back up, data replication will automatically replicate data so that that database instance is caught up to speed. Or in the ideal scenario, when it's not down, when both are up, one active, then the data replication will still happen and replicate data continuously, so database 2 have all information from database 1. And this replication should happen, you know, you have to define whether you want this to happen every minute, because when it does that, it literally have to freeze the database in order to copy data over, right? So it's up to the developer how they want to configure this piece. But with active passive, right, then you only guarantee database reliability, but you don't guarantee the speed, because all requests still only being handled by one database. All the stress are placed on one database. But with active, meaning both databases are active, the two database instances share the stress, right? So database 1 can handle request 8, database 2 can handle request 2, and that's also increase your speed, because the other user do not have to wait for user 1 action to be finished before the system can handle that request. Okay, so this is like a very high level architecture. Now obviously you can have many more database instances, and they all would just be replicate, right, with one another. So it's up to you on how many database instances you want. Now similar concept apply to the front end and the back end. You should also have multiple instances of your front end, so when it go down, the other front end instances will take over. Back end, when the back end go down, you also have the backup to take over, so that when the back end go down, the front end will still work. It just won't be able to display any data because it cannot pull back anything, right? But this is up to you. Read the books. Go read some more Google to understand this. But if you have questions about this, let me know. This is again a very high level of how to use Jar.io, how to basically map non-functional requirement to a high-level system architecture. Right now with this, if I give this to their team, they know exactly what I want, and they can code or can do the low-level design, actually design out this sub-component, this component, this and this, up to the team desired. Okay? Alright, thank you so much. Email me if you have questions. Again, career fair is very closed. If you need my help with looking at your resume, just let me know. Alright, thank you. Bye bye.